You probably do it 100 times a day. You type a web address, hit enter, and bam, a website just appears. It feels totally instant, right? Almost like magic. But what's actually happening in that split second between your click and the page loading? Well, today we're going to pull back the curtain and show you how the trick is done. So let's talk about what I think is the internet's greatest magic trick, one that gets performed billions of times every single day. It's this incredible journey from raw, jumbled code to a beautiful visual canvas. And it all happens right inside your web browser. Every single web page starts its life looking like this. Just a wall of text. It's the raw blueprint, kind of dry, looks pretty cryptic. And yet somehow, your browser takes that and transforms it into this, a colorful, interactive, and thoughtfully designed page that you can actually use. So that's the big question, isn't it? How on earth does this become this? How does that text transform into a visual masterpiece? What is the step-by-step process going on deep inside your browser's engine room? To get that answer, we need to go inside the browser itself. We're heading down to the engine room to meet let's call it, the internal construction company that builds every single website you visit.
It's called the Render Engine, and honestly, it's the hero of our story today. This thing is the absolute beating heart of your browser. Its one and only job is to take that raw code and follow a super precise construction plan to build the web page that you see on your screen.
And here's a cool fact, not all browsers use the same engine. Google has Blink, which you'll find in Chrome and Edge. Apple uses WebKit for Safari, and Mozilla has Gecko for Firefox. This is the real reason why a website can sometimes look just a little bit different in Chrome than it does in Safari. They're literally built by competing construction companies.
And trust me, this competition has been raging for decades. From Mosaic first introducing images, through the whole browser wars in the 90s, to the rise of Chrome, every new player in the game has been focused on one thing: building a faster, smarter, and more efficient render engine.
So how do these render engines actually do it? Well, it's not chaos and it's not magic. It's a highly organized 5-step plan that developers call the critical rendering path. This is the secret recipe. Let's stick with our construction project analogy. It makes it super easy to understand. First, the engine has to read the blueprints. That's called parsing. Then it builds the structural framework and figures out the decorations. After that, it merges them into a final plan, lays out the foundation, and finally paints the whole thing. Let's walk through it. Okay, step 1. It all kicks off with parsing. This is the absolute first thing that has to happen. The engine cracks open the code files, reads the raw HTML and CSS, and basically translates it all into a language that it can actually work with. This is the moment the contractor reads the blueprints for the very first time.
Now, as the engine is parsing that code, it's actually building two separate plans at the same time. From the HTML, it creates something called the DOM tree. Think of that as the structural skeleton of the house, the framing, the walls. At the exact same time, from the CSS, it's building the CSSOM tree, which is all the style rules, the paint colors, the furniture placement, how everything should look.
Okay, step 3. Now the engine takes those two separate plans, the structure from the DOM and the style from the CSSOM, and it merges them into one final master blueprint, the render tree. And here's where it gets really, really smart. The render tree is all about efficiency. It only includes what will actually be visible on the page. If a developer hides an element with code, it gets left out of this final plan entirely. No wasted effort.
This brings us to the layout phase. With that final render tree in hand, the engine turns into a master architect. It calculates the precise geometry of every single element. How many pixels wide is this button? How far from the top of the page is that headline? Every single dimension and position is figured out and locked in right here.
And at last, we get to paint. This is the moment of truth, the grand finale. The engine takes all that geometric layout information and, pixel by perfect pixel, it draws everything onto your screen. The code has finally, officially, become a canvas.
So, the house is built. It looks great. But what happens if we need to make a change? You click a button, an animation plays. This is where things get really interesting.
especially from a performance standpoint, because not all changes are created equal.
When a page changes, the browser basically does one of two things, a repaint or a reflow. Now, a repaint is cheap and fast. It's triggered by something simple like changing an element's color. The browser just has to redraw that one little part. But a reflow is what we call computationally expensive. That's triggered when an element's size or position changes, and it forces the browser to recalculate the layout for everything around it, maybe even the entire page.
You know, here is the absolute best way to think about it. A repaint is like painting a single wall in your house. Quick, easy. A reflow is like moving that wall. All of a sudden, the entire blueprint of the house is wrong, and everything has to be recalculated. That's exactly why web developers try so hard to avoid causing reflows. They can make a website feel slow, sluggish, and unresponsive. Okay, I want to circle back for a second. Remember that structural blueprint we talked about earlier, the DOM? Well, it turns out it's not just some static plan that's created once and then forgotten. It's actually a living blueprint. So what exactly is this thing? We know it represents the structure of the page, but why is it so important for the interactive, dynamic web that we all use every single day? Why do we call it living?
Because the DOM isn't just a map. It's a living, breathing, controllable entity. It is the actual bridge that connects programming code, like JavaScript, to what you, the user, see on the screen. Anytime a website animates or updates or responds to your click, it's because code is actively manipulating the DOM, which in turn is telling the render engine to repaint or reflow.
So, that leaves us with one final fascinating question. If the DOM is this living blueprint that can be changed, how do we command it to change? How does a language like JavaScript actually talk to the DOM to make websites come alive with interactivity? Well, that's a great story for the next explainer.